In the year 1054 AD, a light appeared in the sky that humans couldn't forget for centuries. Suddenly, in the darkness of night, such brightness spread as if someone had lit a new sun in the universe. This was the same supernova that gave us the Crab Nebula. When you look at it, this nebula seems like just a massive pattern of colorful clouds. But this isn't just beauty. The energy hidden inside it is so extraordinary that if someone could feel it directly, it would be beyond human understanding. The Crab Nebula is a mysterious place in our Milky Way galaxy that is constantly changing, glowing, and holding within it a pulsar, a neutron star that spins 30 times every second, and with each rotation throws energy across millions of kilometers. This nebula is about 6,500 light-years away from Earth. Even being so far, its light still reaches us today. Just think about it. How long that light's journey is, how slow, and yet how lasting. The Crab Nebula isn't just an astronomical object but a time machine. Every filament, every glowing stream tells us the story of a supernova explosion that happened 900 years ago. That explosion which destroyed an entire star in a moment and scattered its matter across space. This matter is now moving inside the nebula, creating intricate patterns, like the universe is painting on its own canvas. But this story isn't limited to just visible beauty. The Crab Nebula is an extremely energetic region. Its pulsar, a compact neutron star, releases so much energy with every rotation that it could wrap our entire solar system in waves of light and radiation. The magnetic field lines are so powerful that they warm matter with their movement. They twist and spiral the filament structures. There's movement everywhere here, but this movement isn't visible to our eyes. Only specially tuned telescopes can sense it. Every color hidden in this nebula, every light's glow, every particle's motion is a challenge for human science. The Crab Nebula reminds us that the universe isn't just vast but also alive. It holds within it the story of life and death, explosive energy and calmness combined. And as we get closer to this mysterious object, we understand that what we see in the sky is only the surface. The real power, the real mystery is hidden inside the Crab Nebula. Now when you see it in the sky, understand that this isn't just a beautiful nebula. It's a symbol of those cosmic forces that we can feel but cannot fully understand. The Crab Nebula is a starting point for us. It's the first step of this cosmic journey from where we'll begin to see the energy, mystery, and future possibilities inside it. The glow of the Crab Nebula doesn't just show beauty, but tells us that everything in the universe keeps changing. In the middle of this nebula is a small but very powerful star that scientists call a pulsar. This pulsar spins 30 times every second. Think about it. Such fast speed that it fills the things around it with waves of electricity and light. This is why the Crab Nebula constantly glows and changes, but it's not limited to just the glow. The matter inside the Crab Nebula is divided into different colors and threads. These threads are constantly moving. They create spirals, twist, and sometimes suddenly expand rapidly. This movement shows us that the universe isn't static. This pulsar creates a magnetic field around itself that pulls and bends matter with its motion. Every filament, every color, every light pattern is part of this energy. Imagine so far away in the universe, in a place not before our eyes, such power and activity is happening. The Crab Nebula shows us that cosmic energy isn't limited to just big explosions. It constantly stores and releases energy within itself every second. This same energy causes stars, planets, and galaxies to form and change, and this is the Crab Nebula's greatest beauty. It shows that death is also part of creation. The star that created this nebula ended, but its energy is still alive. That energy is so strong that even centuries later it's visible to us. It explains that nothing in the universe is permanent. Everything is changing. The Crab Nebula isn't just colorful patches to look at. It's like the universe's heartbeat. Every filament, every glow, every motion tells us where the energy is coming from and how it's spreading. It gives us a new perspective that the universe isn't just beautiful to look at, but is alive, changing, and powerful. And now as we move forward in this cosmic journey, we'll see how the energy coming from the Crab Nebula's pulsar is shaping the universe in even bigger ways. Every light burst, every movement tells a story of life and death, a story of energy, and a story of the universe's changing colors. The Crab Nebula isn't limited to just its central pulsar. The space outside it also tells its story. When this star exploded, it spread all its energy and matter into the universe. This matter creates spirals, loops, and tangled threads that interact with light and radiation. Scientists call these threads filaments. In these filaments, every color and every pattern shows different energy levels. The red color shows that hydrogen gas has heated up. Blue shows that oxygen and heavier elements are moving so fast that we can see their effect in light. This movement seems very slow, but on a cosmic scale, it spreads at speeds of thousands of kilometers per second. Think about it. Such fast speed that's hard for us humans to understand is common here. The Crab Nebula tells us that a star's death isn't just ending. Its matter and energy spreading into outer space can give birth to new stars, new planets, and sometimes new galaxies. Every filament is in itself a small story of the universe where chaos and order exist together. But that's not all. The structures at the Crab Nebula's outer edge also tell us about time's currents. From these filaments' movement, we can understand when this explosion happened, how much energy was released, and what might happen next. As energy travels through space, it interacts with its surrounding cosmic environment. This interaction gives us clues about cosmic pressure, magnetic fields, and radiation. And the most surprising thing is that the Crab Nebula's energy is still growing. The pulsar releases energy every second, and the filaments absorb that energy to create new patterns. This shows that the universe never rests. Here, even death turns into creation, and old things give birth to new things. From our solar system, thousands of light years away, this nebula gives us perspective on a cosmic scale. Compared to our Earth and our lives, the Crab Nebula is a reminder that the universe is very big, very fast, and very dynamic. Here everything moves, everything evolves, and everything is alive in its own way. As we move further in this cosmic journey, we'll see how the Crab Nebula's internal energy, filaments, and pulsar together are creating an invisible cosmic network that shapes the entire universe's dynamics. And this is the mystery we need to explore ahead, that invisible energy and motion that shows us the universe's real heartbeat. The Crab Nebula isn't limited to just its filaments and pulsar. This nebula creates echoes throughout its entire galaxy. When this star exploded, its energy and matter disturbed the surrounding space. In this region of the Milky Way, every explosion, every radiation wave slowly spreads and interacts with nearby gas, clouds, and stars. We can call these cosmic ripples. These ripples seem very slow, but instruments that measure them show how much power is hidden in them. The Crab Nebula's energy waves travel for many light years. As these waves collide with magnetic fields, small shocks and currents form in the surrounding space. These currents then carry information and energy to even more distant regions. The motion and turbulence in the nebula's outer layers interact with the rest of the matter hidden in the galactic plane. Sometimes this interaction triggers new star formation, meaning the energy from the Crab Nebula's death itself starts a new creation process. In a way, this nebula is working like a pulse in the Milky Way's ecosystem. And the most amazing thing is that we can't see this echo directly. We have to understand it with the help of telescopes and sensors. X-ray, gamma ray, and radio wave observations show how the pulsar's energy is spreading around the nebula. Every pulse, every filament's vibration is bringing subtle but constant changes to this part of the Milky Way. Looking at the Crab Nebula's galactic position also helps us understand that the universe isn't just about localized events. Every supernova, every nebula, and every pulsar is connected in a network. The Crab Nebula's vibrations also affect the Milky Way's other stars and clouds. Like some huge invisible string connects everything. From our Earth, thousands of light years away, this nebula gives us a cosmic scale perspective. It shows that stars' death and energy redistribution are part of the galaxy's rhythm. Every pulse, every filament, every ripple, all together shape the Milky Way. And as we move forward, we'll see how the Crab Nebula's internal energy and filaments are creating an invisible cosmic network that controls the universe's real heartbeat. The beauty of the Crab Nebula isn't limited to just the surface or visible filaments. Its inner structure is very complex. From above, it looks like a glowing cloud. But as we dive inside, we see that this nebula is tied in a tangled, twisted network. Filaments aren't just linear. They're creating spirals, loops, and knots. Sometimes it feels like the boundaries of up and down are confusing. You can't tell which layer is in front and which is behind, and this confusion is because of the forces hidden inside the nebula. The pulsar constantly sends magnetic fields and energy winds around itself. This invisible force distorts every filament, twists it, and creates new patterns. We can see it, but we can't fully understand how powerful these forces are. On a cosmic scale, these forces spread across millions of kilometers, and their effect shows on every small filament. In the Crab Nebula, every filament behaves like a microscopic universe in itself. Somewhere gas movement is fast, somewhere slow. Some filaments are made from leftover material from the explosion, while others stay continuously charged by the pulsar's energy. They move in different directions, but overall, they're connected in an invisible rhythm. And the most wonderful thing is that this nebula also shows us the interaction of gravity and magnetic fields. It tells us that stars and matter aren't just simple objects. They move in an intricate dance of forces. This illusion of up and down explains that the universe isn't just on the surface, but behind everything are many layers and dynamics hidden. As energy travels in the nebula, it interacts with the surrounding space. Cosmic rays, radiation, and magnetic field interactions keep changing the nebula's shape and patterns. The Crab Nebula is a kind of living laboratory where even after death, forces are acting so fast that we can only observe them, not control them. Our eyes can see this beauty, but the mind can't fully understand it. This confusion of up and down reminds us that as vast and complex as the universe is, it's equally invisible and mysterious. And as we understand more about the forces inside this tangled nebula, we'll see how these energy currents are creating unseen impacts on a cosmic scale that silently but constantly shape the universe's dynamics. The Crab Nebula isn't limited to just glowing gas and filaments. Inside it, high-energy particles and cosmic rays are traveling every second. These particles move so fast that if we let them reach our Earth, detectable effects could show in our atmosphere. But the question is, why does this energy only circulate there? And what effect does it have on the surrounding universe? The pulsar constantly releases energy from its core. This energy isn't limited to just light or radiation. It spreads like an invisible wind in the nebula. It distorts filaments, twists magnetic fields, and creates new patterns. On a cosmic scale, this is continuous motion that continues for thousands of years. The Crab Nebula perfectly maintains this motion. Even after death, energy here never ends. And the most fascinating thing is that these high-energy zones of the nebula are never predictable. Sometimes one filament explodes. Sometimes another particle stream becomes very fast. The impact of these unseen currents goes not just to the nebula, but to the surrounding space. Cosmic rays travel in every direction, and when they interact with other stars or gas clouds, new and fascinating phenomena are born there. The Crab Nebula shows us that energy in the universe doesn't just transfer but also transforms. Even after death, this transformation keeps continuing. The pulsar's energy accelerates hydrogen, oxygen, and heavier elements, creating new patterns, new loops, and new motions in the filaments. Science can observe it but can't fully understand it. From our solar system, thousands of light years away, this nebula gives us perspective on a cosmic scale. What seems static on Earth is dynamic and ever-moving in the universe. This energy of the Crab Nebula reminds us that cosmic forces never rest. Every particle, every filament, every ray is part of the universe's unseen dynamics. And as we explore the energy flows of this nebula deeper, we'll see how these currents are creating ripples throughout the Milky Way. This isn't just a nebula but a living network that carries the universe's heartbeat in invisible threads. This flow of energy will show us ahead how the universe's small and big systems are interconnected, and how the Crab Nebula is playing a central role in those connections. The most mysterious part inside the Crab Nebula is its central neutron star that we call a pulsar. It looks like just a tiny dot, but it has so much density that if you take a spoonful of its material, its weight would be as much as the entire Mount Everest. Think about it. Something so compact and extreme remains invisible to our eyes, but it's the source of the entire nebula's motion and energy. The pulsar rotates every second, many times per second. This rapid rotation generates so much magnetic field that the surrounding space gets distorted. The Crab Nebula's filaments, gas clouds, and cosmic rays remain trapped in this invisible magnetic net. Science can observe it, but fully understanding is difficult. It's like the universe's hidden engine that never tires. And the most interesting thing is that the pulsar's rotation doesn't slow down but keeps distributing energy slowly over time. The magnetic fields are so strong that they even twist the paths of light and radiation in nearby space. The high-energy particles in the Crab Nebula are accelerated by the pulsar's magnetic activity. This chain reaction delivers energy to every corner of the nebula and keeps structures in constant motion. Scientists still haven't understood what physics is going on inside this neutron star. Some things are beyond classical physics, like how can matter be so dense? How does energy release so fast? And how are these invisible magnetic fields working on such a large scale? The Crab Nebula shows us that there's still much in the universe that's unknown and fascinating. From our solar system, thousands of light years away, this hidden engine teaches us that even after death, stars shape their surrounding environment. Filaments, cosmic rays, and magnetic fields leave subtle but continuous effects not just inside the nebula, but also in the surrounding cosmic environment. This is a reminder that everything in the universe is interconnected, and the Crab Nebula's pulsar is the beating heart of that interconnection. And as we move forward, we'll see how human observation tries to detect this hidden energy. Telescopes, satellites, and sensors show us light, radiation, and magnetic signals. But still, the full power and mysteries remain beyond our understanding. This mystery makes the universe so fascinating, and the Crab Nebula is the center of that mystery. Crossing this vast cosmic expansion spreading up and down, suddenly it feels like our eyes perhaps can't fully understand this view. The more we see, the more we realize how limited human vision is compared to this infinite structure. Here, light isn't just light but the color of stories hidden in space-time's depth, and our eyes can catch only a small part of these colors. Slowly, we enter that region where light starts losing its old identity. Here, infrared, ultraviolet, and those unseen cosmic frequencies mix together to create patterns that the human eye can never understand. Maybe that's why scientists build telescopes, because our vision doesn't have the ability to see this true universe. Our journey starts opening this limited vision like a mirror. What seems like white light to us is actually a complex dance of millions of wavelengths, where we see darkness, Dark matter is holding the entire galaxy with its silent pressure, and what seems like emptiness is actually an energy-filled river that our eyes can't catch. In this meeting of darkness and light, that region comes before us where dust clouds and magnetic fields together create a strange glow. This glow confuses the human eye. Sometimes it feels like something is near, then suddenly it disappears. Like space is trying to teach us that seeing doesn't mean just looking with eyes but understanding. A little further, thin lines of stars bend to create a strange curve, and our vision stops for a moment. Is this really bending light, or have our eyes lost the meaning of this depth? Maybe both are true because space-time itself changes its shapes, and our eyes only catch the shadows of those changes. For a moment, it feels like the universe is testing our vision. How much can you see? How much can you understand? And to what extent can you cross your limits? Like it's softly telling us that reality isn't just what's visible, but also what's beyond sight. And with this realization, our journey becomes a little deeper, where the ability to see becomes not just a test of eyes, but of the mind. The Crab Nebula's glow, its pulse, its rotating filaments, what we see today isn't the result of something slowly built. Its beginning happened at such a moment that was so fast, so powerful, brought so much light that the entire Milky Way shook with that shock. That same moment, its supernova explosion. Just imagine, 1,000 years ago, somewhere far on our Earth, people suddenly see such a star in the night sky that's shining like the sun. That wasn't ordinary beauty. It was a star's last scream. A massive star that burned for millions of years suddenly collapsed under its gravity's weight, and then burst in an energy storm in just 1 second. That explosion's brightness was so intense that people on Earth could see it even during the day. History books record that this guest star kept shining in the sky for several weeks. People didn't know what it was, but that was the moment that gave birth to today's Crab Nebula. This supernova's blast didn't just illuminate space. It threw matter with such force that it's still moving today. The filaments whose movement seemed slow to us were actually spreading outward at speeds of millions of kilometers per second. This same outward motion creates the Crab Nebula's shape today and defines its glowing boundaries. But inside this cosmic destruction, another story was hidden. A small, extremely dense core that we today call a pulsar. This same pulsar is that explosion's heart. It's the reminder that even inside destruction, there's a spark of creation. The Crab Nebula's past teaches us one more big thing, that nothing in the universe is permanent. What's shining today can fade tomorrow. What's calm today can explode tomorrow. And what seems dead to us can give birth to new cosmic systems by creating energy and structure. This supernova shows us that time doesn't just move forward. It also keeps the past story hidden in its texture. When we look at the Crab Nebula, we're not just seeing a nebula. We're seeing an echo of an explosion sound that rang in space 1,000 years ago and whose effect is still traveling today. And this same echo gives us invisible clues about how energy evolves, how matter creates shapes, and how the universe writes its story. This is both a pointer to the past and a bridge to the future. Now, as we move forward in this journey, we'll hear that pulsar's voice, those signals that try to tell stories faster than light, signals that are perhaps the universe's language and perhaps a message for us too. The Crab Nebula's heart, that small rotating pulsar, isn't just a cosmic relic. It's a source in the universe that's constantly speaking. But its voice isn't like humans. This voice comes in the form of light flashes, magnetic pulses, and vibrations spread in space-time. Every second, this pulsar sends intense flashes because of its rotation. Imagine an object that's as small as a city but rotates so fast that it completes a full circle 30 times in 1 second. This rotation isn't an ordinary event. It's the result of leftover energy from that supernova explosion, and every rotation is a signal, a message of pure energy. Our telescopes catch these flashes. Scientists say they're just like a heartbeat, regular, rhythmic, predictable, like the universe has set a clock. But this clock doesn't measure time. It tells energy's story. Every pulse tells how the pulsar's energy is decreasing, how the magnetic field is changing, and how it's shaping the nebula around it. But not just pulses. Inside the Crab Nebula is another phenomenon we call light echoes. The light that came out after the explosion is still reflecting off the nebula's dust and gas. This means a 1,000-year-old event still appears today in the form of glow. Like some old memory suddenly collides with some new surface today and comes back alive. These echoes tell us we're not just seeing stars. We're seeing their memories. Through light's eyes, we see the past unfolding in the present. This thought itself is so poetic that space feels like a book where every glowing particle is part of some old chapter. The Crab Nebula's these signals and echoes aren't just scientific data. This is the universe's conversation, a conversation. The pulsar's every beat, every flash, every particle stream says that energy doesn't lose. It just changes form, that even after destruction, rhythm remains, that even inside chaos, a pattern is hidden. And in understanding this same pattern, our human curiosity gets tested again and again. We sit far away listening to these pulses, like some cosmic lighthouse is shining in the darkness, a reminder that the universe isn't silent. It's constantly speaking, just its language is different. Now, as these signals show us the past, they also open a doorway for the future. What might happen ahead? In which direction will the Crab Nebula's energy go, and can its effect ever reach near us? All this will become part of that coming story. The Crab Nebula's energy isn't just the past's echo. It's also a wave moving toward the future. When the pulsar throws particles into space with its intense pulse, it doesn't remain limited to just its boundary. Its reach spreads light years away. This same energy, these same charged particles might one day change some new region. Imagine somewhere in space that's calm, stable, cold. Suddenly, the Crab Nebula's particle wind reaches there. This isn't just wind. It's a storm of high-energy cosmic rays. These rays are so powerful they can enter inside matter and change atoms. And if they reach some young cloud of gas, that same cloud might give birth to some new star in the next millions of years. This thought itself is breathtaking. One star's death becomes the reason for another star's life. The Crab Nebula's future is just like this, a silent architect who's shaping space while sitting far away. But naturally, a question arises here. Can this energy ever reach our near-Earth neighborhood? The straight answer is not now. The Crab Nebula is thousands of light years away from us. Its radiation isn't intense enough to reach our planet. But the future is infinite, and the universe isn't static. Energy spreads. Boundaries move, and cosmic currents can change direction anytime. If hypothetically the Crab Nebula's particle storm came near our solar system, it would rewrite our space environment. Magnetic fields would get disturbed, satellites could face disruption, and unusual auroras would appear in our atmosphere. Bright, powerful, alien auroras that would fill the entire Earth with colors. But fascination is more important than fear, because the Crab Nebula's energy is more transformative than destructive. It's the universe's painter who puts new strokes on dark canvas. The nebula's outer shock waves have already pushed interstellar clouds before, compressing them to trigger star formation. In the future too, this ripple effect will continue to travel far and wide, and the most interesting thing is that the pulsar is slowing down. Every year it loses its rotation speed a little. This means one day its energy will also decrease. But even after that decrease, the impact from which this nebula is forming will keep traveling in space. Energy never stops, it just changes paths. The Crab Nebula gives our imagination a new direction, that the future isn't just ours but also of those stars that turned to ash thousands of years ago after burning. Their light, their pulse, and their left energy are still giving the universe new shape. And as this journey moves forward, we reach one last question. So much beauty, So much power and such an ancient story. What's its meaning after all? This same question will take us to the next and final turn, where the Crab Nebula won't just remain a nebula, it'll become a cosmic truth. The Crab Nebula's glow, its expanding filaments, its pulsing pulsar, seeing all of this, one thing is felt again and again. The universe isn't just a game of distances and numbers. It's a story, a deep, long, infinite story that stars write with their birth, their struggle, and their death. The Crab Nebula is one of the most beautiful, most emotional chapters of this story. A star that once illuminated surrounding worlds with its warmth suddenly broke. Its bones, those glowing filaments, are still floating in space today. Its heart, that fast rotating pulsar, is still sending its light today, and its form, that vast cloud of colors, still forces us to think how deeply destruction and creation are connected. We look at this nebula, and we realize that nothing in the universe is permanent. Everything changes. Stars change, galaxies change, time changes, and maybe we too. But among this constant change, one thing always remains: curiosity. That same curiosity that forced humans to look at a guest star shining in the night sky. That same curiosity that lifted telescopes toward the sky. That same curiosity that brought us on the journey to understand the mysteries hidden inside the Crab Nebula. And as we stand in this final moment, it feels like the Crab Nebula is giving us a calm, deep teaching. That beauty isn't just in symmetry, it's in chaos too. That death isn't the end, it's the first step of some new beginning. That the universe didn't come to scare us but to explain. And this understanding makes us a little humble, a little aware, and much more human. The Crab Nebula, as far as it is, feels equally close because it shows us our place. We're small but not lost. We're limited, but our ability to find light in darkness is infinite. We're made of dust, but that same dust gave birth to stars, and it created the Crab Nebula. The end of this cosmic journey isn't just this. It's the beginning of that realization that the universe is endlessly alive, and we're a small part of that same vast heartbeat. The Crab Nebula reminds us that whether it's darkness, explosion, or complete stillness, there's meaning everywhere. There's a story everywhere. There's light hidden everywhere that reaches us someday or another. And with this same realization, this journey doesn't end, it completes. Take one last look at the Crab Nebula and feel that you haven't just seen a nebula.